In this video, let us solve more problems based on trigonometric identities. So here we've got the problem. What we have to do here is we need to prove that cot A plus cosecant A minus 1 over cot A minus cosecant A plus 1 equals 1 plus cos A by sin A. So let's start off with this term, that is cot A plus cosecant A minus 1 over cot A minus cosecant A plus 1. So let's take that. So let's write cot A plus cosecant A as it is. What I'm going to do to 1 is I'm going to replace 1 by cosecant square A minus cot square A. So if you're wondering how I did that, we know that 1 plus cot square A equals cosecant square A, right? So we can write this as cosecant square A, shift cot square A to the right hand side, becomes cosecant square A minus cot square A equals 1. So I've replaced 1 by cosecant square A minus cot square A over cot A minus cosecant A plus 1. So now what I'm going to do is cot A plus cosecant A minus of, now this is of the form A square minus B square. So cosecant square A minus cot square A can be written as cosecant A plus cot A, that is A plus B into A minus B. Cosecant A plus cot A into cosecant A minus cot A, right, over cot A minus cosecant A plus 1. So now if you notice carefully, in these two terms, this one and this one, you consider this is one term, this is one term, separated by a negative sign, right? Now cot A plus cosecant A, cot A plus cosecant A, the two terms are common in both of them. So let's take it out. That is cot A plus cosecant A. Let's take it out as common. So if you take it out as common, this will get replaced by just 1 because cot A plus cosecant A to 1 gives you cot A plus cosecant A, right? And then negative sign here minus, we've got what's going to be left now. If you take out cosecant A plus cot A, only this is going to be left. So let's write cosecant A minus cot A, right? So over cot A minus cosecant A plus 1. So what's the next step? So let me draw a line here. So the next step is going to be cot A plus cosecant A. Let's write this in brackets and open another bracket. Let's open these brackets now. 1, negative of cosecant A is negative cosecant A, and negative of negative cot A is positive cot A, right? Over cot A minus cosecant A plus 1. Now if you look carefully, these two terms are same. Plus 1 minus cosecant A minus cosecant A and cot A cot A. It's just rearranged, but these two terms are very same. And the reason we can strike these off is because there is a multiplication symbol here. So this and this gets cancelled. We are left with cot A plus cosecant A. So now we need 1 plus cos A over sin A. So how are we going to get that? Let's write cot A as cos A by sin A. Pretty simple. And cosecant A is a reciprocal of sin A. So let's write this as 1 by sin A. These are the two fractions whose denominators are the same. So therefore, sin A becomes a common denominator. And then on top, we've got 1 plus cos A or cos A plus 1, all the same. So here we are, right hand side. So we've started off with this and we've proved that this is equal to this. Here it is. The reason, now let's discuss why I did this here, why I wrote in the place of 1 this one. Only then were we going to get something of this sort. So it's more of a trial and error method. It's not that you need to straight away know this, but you can, of course, try your methods, and these problems can be solved by more than one method. So go ahead and try whatever you feel like. All you need to get at the end is right hand side, just like how we've got here. Let's quickly solve another problem. We need to prove that the square root of secant squared theta plus cosecant squared theta equals tan theta plus cot theta. This is not as complicated as it looks. If at all, it looks complicated. Now, secant squared theta can be written as 1 plus tan squared theta. The reason I'm doing this is because we need tan and cot in the right hand side. That is why. And cosecant squared theta can be written as 1 plus cot squared theta. So now we can write this as 1 plus 1 is 2. 2 plus tan square theta plus cot square theta. Now the next thing is square root of tan square theta plus cot square theta. We've got almost a square plus b square plus 2. We need av. So let's write tan theta cot theta. You may wonder, whoa, how can we just bring in this? Well, the reason I've brought in this is because tan theta into cot theta is 1. So it's as good as writing 2 or 2 tan theta cot theta, because tan theta is a reciprocal of cot theta, or cot theta is a reciprocal of tan theta, and they both cancel each other. So that's why I've written this. So let me write in the brackets here, tan theta into cot theta equals 1, right? So now tan square theta plus cot square theta plus 2 tan theta cot theta is nothing but tan theta plus cot theta the whole square. That is a square plus b square plus 2ab is nothing but a plus b the whole square. So root of something the whole square is just that. So square root of tan theta plus cot theta the whole square is tan theta plus cot theta. So here we are, right hand side. So we've started off from this and we've ended here. So we proved that the root of secant square theta plus cosecant square theta equals tan theta plus cot theta, right? So this ends this video, which contains a set of 2 problems. I'll see you further in the forthcoming videos with more problems on these topics.